Grade 9s, let's review for our math midterm. Starting with square roots. How do you find the square root of a fraction? Well, take a square root of a fraction like 9 over 121. You take the square root of 9 and the square root of 121. The square root of 9 is 3, and the square root of 121 is 11. And that is your final answer. If you want to find the square root of a decimal, you could also change it to a fraction if you wanted to. But if you had a calculator, you can just use the calculator, press the square root of 3.24, and you'll get 1.8. Another type of question that often confuses students is to calculate the number whose square root is. Oftentimes, students will just take the number that they're given and just square root it, but that's not what the question is asking. The question is saying, if I take the square root of some number, it's going to be, for example, like 0.7. Well, what number has a square root 0.7? It's the number that if I multiply 0.7 to itself, that will be the number whose square root is 0.7. Same thing with fractions. So I want to know who has a square root of 2 over 13. Well, to do that, all I have to do is multiply 2 over 13 to itself. And then I know that 4 over 169 will have a square root of 2 over 13. Which decimals and fractions are perfect squares? You have to show how you know. If we look at something like 7 over 63, it doesn't look like a perfect square. 7 is not a perfect square. 63 is not a perfect square. But I do know that I can simplify 7 over 63. And it's the same as 1 over 9. And here I know that 1 is a perfect square and 9 is a perfect square, meaning I can take the square root of it. It's 1 over 3. So 1 over 3 times 1 over 3 would give me 1/9. So I know that 7 over 63 is a perfect square. What if we want to try a decimal? Like, let's say 4.9. Now you might think, well, 49 is a perfect square, so 4.9 might be. If you were to change it to a fraction, you would actually see right away that it's not. But another way to check is to take the square root. So if you have your calculator, take the square root of 4.9, and you get this long decimal. You get something like 2.2135994, and a whole bunch of decimals after that. What this tells me is that the square root of 4.9 is both non-terminating and non-repeating. So non-terminating, non-repeating tells me that 4.9 itself is not a perfect square. It does not have a terminating or repeating square root. And lastly, use any strategy. In this case, we want to estimate these square roots using benchmarks. So if I have a square root like 1 over 35, if I notice that the parts of this fraction are really close to a perfect square, I can just say, well, 1 over 35 is really close to 1 over 36. So if I take its square root, it's a pretty good estimate. So for the square root of 1 over 35, I'm going to say it's approximately 1/6, and that would be okay. If I take the fraction next to it, I can use the same strategy. Like 65 is really close to 64, so I can just take the square root of 64 and 4. But let's say you wanted to try something else. I could take this and turn it into a decimal. So for example, if you were trying to figure out the approximate square root of a decimal, you might do something like this. So the square root of 16.25, I don't know for sure, but it happens to be between two square roots I do know. So I know the square root of 16, I know the square root of 25. The square root of 16 is 4, the square root of 25 is 5, and 16.25 is really close to the square root of 16. So I'm going to say it's about 4.1, maybe even 4.01. Next, let's look at powers. Write each product as a power, then evaluate. If I take a look at this repeated multiplication, the base is going to be -3, and I just count. How many do I see? There's 7. So -3 to the 7th is the power. To evaluate, I just calculate. -3 times -3 times -3 times -3 times -3 times -3 makes negative 2,187. In your calculators, you could just do 3 to the 7th and just recognize that the product will be negative at the end because there's an odd number of factors. If I do the same thing with question E, I have negative 10 to the 5th. There's a trick to powers of 10 where I know that the number of zeros in the evaluated form or the standard form is going to be the same as the exponent. Evaluate these expressions. Now, while some of you have calculators that can calculate this when you punch them in, we're expecting you to show your work, show that you understand order of operations. So if we take this expression, 9 squared divided by -3 cubed plus 5 squared minus 2 to the 5th, you have to be able to show us that you know what operations to do first in order to get the correct answer. In this case, I'm going to just evaluate all of the powers first. So 9 squared is the same as 81 divided by -3 cubed is the same as -27. 5 squared is 25. And just be careful, 2 to the 5th is not the same as 5 squared. It's the same as -32. Next, I'm going to divide before I add and subtract. Not just because it's first, but because of order of operations. 81 divided by -27 is -3, plus 25 minus 32. At this point, I'm just going to add and subtract these values, and I get my final answer, which is -10. Express as a single power. So with these expressions, I want to be able to use my exponent laws in order to either rewrite them as a single power or the fewest number of powers possible. If we look at this example here, I have -3 to the 6th divided by -3 squared times -3 to the 4th. I notice that all of these powers have the same base, which means I can use some exponent laws. When I have the same base and I'm dividing, I subtract my exponents. So I get -3, 6 minus 2 is 4, times -3 to the 4th. Now I am multiplying two powers with the same base, which means I add my exponents. My base stays the same, -3, and I add my exponents. 4 plus 4 makes 8. And that is my single power. Next question says simplify, then evaluate. So I need to simplify first using my exponent laws, and then I need to calculate the standard form. So if I take a look at the first question here, I have 6 squared to the 8th. This is a power of a power divided by 6 to the 4th squared. So another power of a power. When you have a power of a power, you can multiply the exponents. So 6 squared to the 8th is the same as 6 to the 2 times 8, which is 16, divided by 6 to the 4 times 2, which is 8. Now I'm dividing two powers with the same base, which means, again, I can subtract my exponents. My answer is 6 to the 8th. So I've simplified my expression, but it does say evaluate. So I got to take my calculator. 6 times 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 6 gives me 1,679,616 as my final answer. Let's do one more. Here, let's do 4 times 9 to the 4th plus 3 to the 5th squared. For the first term, I'm just going to multiply what's in the brackets. I could do product of powers, but that's okay. So I have 36 to the 4th. Here I have a power again. So that is 3 to the 10th. One thing to note here is I cannot simplify this expression anymore. Okay, first of all, I don't have powers with the same bases. So I don't have a rule for that. And also I'm adding. I'm not multiplying or dividing. So I cannot apply another rule here. At this point, I would just have to evaluate 36 to the fourth plus 3 to the 10th. I cannot simplify that expression anymore. Surface area. So I want to find the total surface area of this 3D object. It's a cylinder plus a rectangular prism, and they meet at this point here. In order to find the total surface area, I need to find the surface area of the cylinder part plus the surface area of the rectangular prism. And I'm going to subtract for that the area that they overlap, in which case it's one of the ends of the rectangular prism. If I know the formula, I can just use the formula for the surface area of a cylinder. It looks like this: 2 pi r squared plus 2 pi r h. The values for pi, well, pi is 3.14. But the radius I get in the question itself, it's 9.6 centimeters. Just be careful. Sometimes the question will give you the diameter, in which case you have to take half of it. It also gives me the height of the cylinder, which in this case is 3.5 centimeters. And again, I'm just going to use pi equals 3.14 for my calculations. Just so I don't have to write too many decimals, I'm just going to round it off. It's about 790 centimeters squared. Okay, don't forget your units. Next, I'll find the surface area of the rectangular prism. There's different forms of this formula. This is the one I'm going to use. Find the surface area however you need to, but I just need to know the length, width, and height, and it's given to me in the question. So I substitute the values into my formula, after which I just calculate it. I get 162.50 centimeters squared. Okay, next I need the overlap. So where they connect, we lose area. That area looks like a square. That's going to be 2.5 by 2.5, which means the area of overlap is 6.25. So just plugging in all these values into my original idea. The cylinder is 790 centimeters squared. The rectangular prism is 162.5. And then I'm going to subtract 2 times 6.25. I need to do 2 times because where they connect, I'm losing 2 faces. Altogether, it's about 940 centimeters squared. Don't forget your units. Understanding polynomials. Let's say you had to sketch the tiles that represent 4n squared minus 2n minus 3. To represent 4n squared, I'm using 4 of the big square tiles. Because it's positive, I'm not going to color them in. After that, I need 2 of the n tiles, or the 1 degree tiles. They're negative, so I color them in. And then I need 3 1s, but it's also a negative, so I color them in. And that's my representation. 2. Identify the variables, coefficients, and constant terms in each polynomial. If we look at this polynomial here, 5y minus 6 minus y squared, I want to identify the variables. In this case, there's only one. It's the letter. It's y. Even though there's 2 of them, the variable is the same. It's y. I want to identify the coefficients. It's the number multiplying my variable. So I have 5 there, and even though it looks like there's nothing beside the y squared, it's the invisible 1, so negative 1. And the constant term is the number that's by itself. Now, it is negative 6 in this case, not just 6. Classify each polynomial below. Let's look at a couple of these. If I looked at 3f plus 5, it has 2 terms. Terms are usually separated by addition or subtraction. It's also known as a binomial because there's 2 terms. It is degree 1 because the term of the highest degree is 1, that 3f term. If I look at 5h minus 6 minus h squared, there's 3 terms, which makes it a trinomial. The term with the highest degree is that negative h squared, which is degree 2. So I say that polynomial has degree 2. Almost done. Now we're adding and subtracting polynomials. Let's say I want to add these two trinomials. Let me just write them out. So when adding polynomials, just remember you need to add like terms. So if you imagine like terms using the same tiles, that's one way to remember it. But if I have 1p squared plus 3p squared altogether, that's 4p squareds. If I have 3p and 1p altogether, that's 4p. If I have 5 1s and a 1, that makes 6. I cannot combine p squareds and p's. Those are different tiles. They're not like terms. If I were to subtract these two polynomials, let me just write it out. From that, I'm going to subtract minus 2t squared minus 5t minus 1. Same idea. I'm going to just subtract like terms. So I look at my like terms. I have negative 4t squared minus negative 2t squareds. I can just look at it as subtracting the coefficients. Negative 4 minus negative 2 leaves me with negative 2t squared. Minus 3t minus negative 5t leaves me with positive 2t. 9 minus a negative 1 gives me a 10. Okay, so work on your integer rules, especially when you're subtracting. Another type of question you might get looks like this. If I add two polynomials together and it tells me the sum, what is that other polynomial? So it's saying that 3c minus 7 plus something should give me the sum of 15c plus 6. A couple ways you can do it. You can either subtract, so I know that 15c minus 3c makes 12c, or we can just kind of think 3c plus what makes 15c. And then minus 7 plus 13 gives me my positive 6. So I know that this is that missing number, missing polynomial. Here's a perimeter question. Let's look at this rectangle. Just remember that perimeter is the distance around the shape. Some people confuse it with area, where we're just multiplying the values. We're not. If my shape looks like this, and its width is 2a, and its length is 3a plus 5, because it's a rectangle, I know what the opposite lengths are, and all I have to do is add them all together. So 2a plus 3a plus 5 plus the other 2a plus 3a plus 5. Again, when adding polynomials, add like terms. So all of my a terms, I will add together. So 2a plus 3a plus 2a plus 3a means I have 10 a's, and 5 plus 5 makes 10. So my polynomial looks like this. The question does say to determine the perimeter when a equals 3. So here I just substitute the value 3 in for a. 10 times 3 plus 10 is 40. Multiplying and dividing polynomials. Let's say I have to multiply 5 times negative 7 plus 2x. So I can think of this as the same as there being 5 groups of negative 7 plus 2x. You can imagine it using tiles, but ultimately what I'll have is 5 groups of negative 7 plus 5 groups of 2x's. If I multiply these out, that's negative 35 plus 10x. So if you've learned distribution, it's the same idea. If I'm going to divide instead, if I have 15 minus 21q plus 6q squared divided it by negative 3. So I'm taking this and dividing it into 3 groups. It's important, though, that I remember to divide each term into those 3 groups. So if I have 15 divided by negative 3, well, 15 divided by negative 3 is negative 5. If I have negative 21q, negative 21 divided by negative 3 is positive 7q. And then 6q squared divided by negative 3 gives me negative 2q squared. If I'm multiplying polynomials together, So here I have something like m times 3m plus 2. Same idea. I'm taking my m, multiplying it to each term inside the brackets. So this is distributive. M times 3m is 3m squared, because m times m is m squared. M times 2 is just 2m. And lastly, if I'm dividing polynomials, you can't see it on the screen, but the question is 14y squared minus 21y divided by negative 7y. Same idea. I'm dividing each of the terms above by that monomial underneath. So I'm dividing them all by negative 7y. 14y squared divided by negative 7y is negative 2y, because 14 divided by negative 7 is negative 2. And then negative 21y divided by negative 7y is 3, just 3. And something to remember is that y squared divided by y is y, and when you divide two y's together, you get 1.